Alright, let's have a look at problem 536, construct binary tree from string. So this video is a follow-up of the previous videos on the binary tree traversal algorithms. So in the previous videos, we covered some basics about binary tree traversal, like pre, in, or post-order traversals, level order traversals, and zigzag traversals, and their variants, and some we didn't cover, like the Morris traversal. Here, this problem actually can be regarded as a continuation of that series. So first, for this problem, in this video, we're going to share a very simple method. So we just need to determine the left and right subtree start, and then we use recursion for the current problem. So we will first look through the statement of the problem, and then we're going to explain the method and the specific procedure. And finally, we share the code and do some test and emphasize one subtle point. So first, let's have a look at the problem statement. So we need to construct a binary tree from a string consisting of parentheses and integers. The whole input represents a binary tree. It contains an integer followed by 0, 1, or 2 pairs of parentheses. The integer represents the root's value, and a pair of parentheses contains a child binary tree with the same structure. So if we stop here and examine this paragraph, actually it gives us a recursion relationship or a recursive structure. So next paragraph is an assumption. So we always start to construct the left child node of a parent first if it exists. So this basically tells us the order, so we have left and right. So let's look at one example to gain some intuition. So in example 1, so this is the depict of the binary tree. So the corresponding string is this one. And then the output, actually, we want to output a tree node. But the output here is a value, so the corresponding node's value. So for example, 4. So this is the root, and 2, 2, 3, 1. So this one. This is the corresponding left subtree. And 6, 5 is the corresponding right subtree. So this is the output. In the actual code, we just need to return the root node. So this is example 1. So from this example, actually we can see the first number. So it's the corresponding root value. So we're going to construct a root from the first number, and then we do the same thing for the left subtree and right subtree. So if we examine like this, so the key point for this problem is that how we get the left subtree and the right subtree. So before we share the method and code, let's look at the constraint. So the length of this string is up to 3 times 10 to the power 4. So it's sort of long. And S consists of digits and open parentheses and close parentheses and negative sign only. So with that said, let's have a look at the method we're going to use to solve this problem. As we mentioned when we analyze example 1, so we're going to determine the start of the left and the right subtrees, and then do the recursion method. So for example, in this one, so this is actually example 1. So if we think of this, it's quite possible it reminds us of the stack abstract data structure. However, for this problem, we will not use stack here, or at least we do not use stack explicitly. So the thing we're going to do is that we just need to find this one. So this is the start of the left subtree, and this is the start of the right subtree. We just need to determine these 2 indexes, and then we extract the number, and then we extract the left subtree and right subtree. Then we just need to do a recursive function. So the thing now is how can we determine the start of the left subtree and the right subtree if we have these subtrees. So here is a basic linear procedure. So this is the corresponding indices for the characters in the string. So if we do a linear scan of this string s, so we're going to introduce a variable called balance. And so balance basically checks if the parentheses are balanced or not. So the principle is like this. When we meet an open parentheses, we're going to increment this balance variable by 1. And if we meet a closed parentheses, we're going to decrement the balance variable by 1. So these two, so this is the index 1 and index 10, mark the start of left subtree and right subtree respectively. So they have a very different character or characteristics than other indices. So for index 1 and index 10, so the balance variable is 1 here, and also the corresponding character is the open parentheses. So that's the main idea. So in order to track this, we just need to do a linear scan. That's all about it. And then we just need to use recursion to build the tree. So now I guess we are ready to share the code. So before we do that, actually, so this problem is quite related to binary tree serialization and deserialization. So it's recommended that we have a look at Leetcode 297. So you are encouraged to have a try. So now let's look at the code. So first, I'm going to step 1. So I'm going to write a hyperfunction. So the hyperfunction basically construct the tree and do the actual work. But an important part is find the left and right subtree starts. So we'll explain this in the code. So for this, I'm going to define a builder function. I'll call it builder, and then we build from this string s. So first, I'm going to treat a special case because the length of s can be 0. In other words, it can be empty. So if not s, I'm going to return null, right? So just return. Then I'm going to determine this index and this index. I will call it left and right. So initially, once we set the left index and the right index, we are basically done. So the remaining work is sort of routine. But for this purpose, I would first introduce the left and right indices. I'll let them equals to length m, which is auto bound because the index for the string s is at most length s minus 1. So this is just for a technical treatment. And then I'm going to introduce the balanced variable. So originally it's 0. And then I'm going to iterate the string s. So for this, because I also need to track the index, so I would call this like use an enumerate function in enumerate s. So basically, if character is the open parenthesis, so I'm going to increment this balanced variable by 1. So if the character is the closed parenthesis, I'm going to decrement this variable by 1. And then in order to determine the left and right, I want to check this condition. The balanced variable equals 1. Because 1 means it indicates something starts, right? Because if it's balanced, it's going to be 0. And if the character is also a start parenthesis, it means it start either left subtree and right subtree. but we start from the left. So the first index we're going to determine will be the left index, right? So if balance variable equals 1 and the corresponding character equals the open parentheses, then I'm going to set the left if it hasn't been set yet. So how we check that? So if left equals length s, so this means I haven't set the left yet. I'm going to set the left equals I. So otherwise, so if left does not equal to length, it means that I already reset the state of left. Then I'm going to set the current index to be right. So in other words, right equals I. So actually, once I set the right, so basically we can break. We do not need to traversal anymore, right? So that's the part that we determine the left index and the right index, indicating the start of the left and the right subtree. And then we're going to do the actual work to get the tree. So first I will denote a root. So basically it's a tree node, right? So what's the value? So value will be so here is the index, right? The starting index to left tree. So before the start index of the left subtree, that's the number. Notice that sometimes it can have a negative sign in front of 4, right? Because the numbers can contain negative sign, right? So this basically is an integer of s, so before left, right? So that's a part. Then I'm going to construct the left subtree, right? So I'm going to construct its left. It's going to be builder, so I'm do a recursion call. So from another string, it's from left plus 1 up to right minus 1, right? So let's examine here. So we are starting from here, so that's left start 1, and then this is the right, so right minus 1, so we are here. So this index actually are very important, so left plus 1, not left. So similarly we can do the right, so I can do a recursive call, and then it's from right. So currently we are in right, so we need to start from right plus 1. So this is also important details. Right plus 1 up to the end, right? That is length s minus 1, right? So here I just want to emphasize that here left plus 1 and right plus 1. So these are important. So once we finish that, we're going to return the root. So that's what the main hyperfunction do. So now we are in the second step to call the function and do the return. So what we want to return is the root, so we'll just call builder. Then we build from the string s. That's about it for this problem. So let me first check a special case and then do some comments. So here this is a mistake. So yeah, it passes the example 1. So now I guess let's check the full test cases. Alright, yeah, it passes all the test cases. So here let me give a quick summary. So for this problem, we're using a method that we first determine the start of left and right subtrees, and then we do a recursion call, right? So the idea is quite similar to the idea we used for doing the in-order traversal, right? So actually the main work is done by the builder function. So the builder function can be divided into two parts. The first part essentially is determine the left-right index for the left and the right subtree, and then we do the actual construction procedure, and finally we do the return. So after this builder function, it remains to call and return the result of the function call. So I guess that's about it for this problem. Thank you very much.